Hi, welcome to another adventure in Molly's Maths. Today is 5th of January and we're going to do some more maths. So, as everybody loves the maths and to get yourself in a good mood, let's get the music on. So, make a good choice in your music selection, get yourself comfortable, and we'll get ready to start with the maths. As I said before, this video is basically an accompaniment to help you with any maths that you're doing on these questions. I would say have a go at the question first, stop the video and then look at the video and see if that's might aid you with the question. You might not even need the video because you might be able to do it well easily without the video, but this is something that you can maybe use. It might be useful to you. Without further ado, let's move on to question one then. Right, question one. Right, all about being a member of a club. There's a club all with members, and all members of this club need to have a badge, a membership badge. So the club, it could be a golf club or it could be a music club. So we've got 140 members and every member needs a badge. But we can purchase these badges in packs of 9. So there's 9 badges in a pack. And the question is, what's the least number of packs of 9 badges we can buy to give all the 140 members a badge? Well, let's have a go then, shall we? So we got the 140. Yeah, so we've got 100 and we've got 140. So what we need to do with 140 is see how many 9s are in 140. So we can divide that by 9. And if you do this on your calculator, you'll find it is 15.55 and 5 recurring forever. So basically that means 15 packs is not going to be enough. So we're going to need 16 packs to give everybody a badge. So 16 packs is the least number we need. So I'm just going to write that down. 16 packs is required. This will actually mean you'll have a few spare badges. But anyway, some members are going to lose their badges and they'll be knocking at the door for some badges, so it's always best to have a few spares. Let's have a look at question 2 then. Ooh, this is everybody's favourite. Fractions, multiplication of fractions. Not something to be feared really, especially when you're multiplying fractions. It's quite easy multiplying fractions. All you've got to do is multiply the top and the bottoms together. So basically what we would do 2 times 1 and 7 times 3. 1 2 is 2. 3 7s are 21. There's your answer. Multiplication of fractions. Now when we're dividing fractions, this is a little bit more tricky, but it's not that tricky if you know the rule. what you need to do is turn one of the fractions upside down. So this would equal, we've got 4.7, and if we turn the second fraction upside down and put the 5 on the top and the 4 on the bottom, we can now multiply them. So basically we've just turned the second fraction upside down. So that's a lot easier now, isn't it? So all you've got to do is 4 times 5 over 7 times 4. What's that going to equal? 4 5s are 20, and 7 4s are 28. So, although it's a division, the trick is, the rule is that you turn the second fraction upside down and it becomes a multiplication. And that's all you've got to do is multiply the denominators together and the numerators together, and that will give you the answer. So it's 20 over 28. But there's one thing you can do with 20 over 28. We can simplify that. So if we've got 20 over 28, what can we do with that fraction to make it smaller? How many 2's in 20? 10. How many 2's in 28? 14. And we can do it again. How many 2's in 10? 5. How many 2's in 14? 7. We cannot get it any simpler than that. So the actual answer will be 5 over 7. If you simplify the answer as well, will probably get you an extra point in the exam. So we've done two things there. We've multiplied the fractions, divided the fractions, and we simplified the fractions. In fact, that's 3 things. Let's move on to the next question. Question 3. Indices. Well, basically, indices, some people find them a bit frightening, but all it means is the number, the small number, in this case we've got a 4, means that we've got to multiply the large number by itself 4 times. So basically this would be 12 times 12 times 12 times 12. And so the answer to this will be quite a big number, and if you use your calculator you will be able to do it on the calculator. It's 20,736. So basically all you do is you multiply the number by itself 4 times. Not too difficult, and yeah, that's all you do. So if it was if the question was 12 to the 2, it would be 12 times 12, which equals 144. So all you do, you just look at the number and multiply it by the number of times. How's that look to you? Let's move on to question 4. Oh, question 4. Again, this might be tricky for people with visual impairment. We've tried to increase the graph into a more easy to read form, but it's still tricky. So basically we'll go through the question together. Nick's bike ride in distance, in miles. So there's a graph here, and on the left-hand side, we've got miles, and it goes from 0 to 20, 20 at the top, 0 at the bottom, and on the bottom axis, we've got the time, and it started at 10 o'clock, and it goes up in single hours up to 2 o'clock in the afternoon. So there we go. So we can see that he's had a bike ride, and the line shows you the distance he's travelling at the time he's travelling. So basically, if we look at we can see where he is in distance compared to time if you go up and across. Let's see what the questions are, and then we'll come back to the graph. Right, how far was Nick travelled from home at 11:30? Well, let's go back to the graph. 11:30, it's in between 11 and 12. So basically we would draw a line from there directly up to where it crosses the graph. And we can see it crosses the graph there. And if we look to the side, it says 12. So that means at 11:30 he had done 12 miles. So we can write that as our answer, can't we? 12 miles. We must write the units or we won't get the marks. What happened between 12 and 1300, which is 1 o'clock? Let's go back to the graph again, have a look. So between 12 and 13, which is here, and here, and here. If we go up to where the line is, the crossing, you can see it's a flat line, and it's stuck on 16. If we go to the edge, it's stuck on 16. So basically, he was on 16 miles from 12 o'clock to 1 o'clock or 1300. What do you think he was doing then? The bike wasn't moving. I'll take a wild guess. I think he was probably having his lunch, eating his lunch. So I would say having a bottle of pop and a sausage roll, probably. Right, the last question, we've got to work out the speed between 10 o'clock and 12 o'clock. And I've given you the formula here. Speed equals the distance divided by time. So let's find out what the distance is. We know that, so basically 10 to 12 is 2 hours. So if we put 2 down for the time and put that down as divide, we've got to find out what the distance is he'd done at 12 o'clock. So let's go back to the graph. 12 o'clock, let's follow the line vertically up until it crosses the line on the graph, and it's crossing at 16. 16. So that's 16 miles he'd done in 2 hours. So let's put the 16 down here. So the speed equals 16 divided by 2. So speed, I'm going to put it underneath it, equals 8. But what 8 what? 8 miles per hour. Now, it's very important that you put those units down because they will get you the marks. The 8 will get you a certain number of marks, but the units, the speed is 8 miles per hour. So that's how fast he was travelling on his bike. maybe you guys can get out and try your bikes out and see if you can do 8 miles per hour for a couple of hours. I think it's pretty good actually, 8 miles an hour. I can do it in a car. But let's move on to the next question. Well, actually, there is no more questions. I think that's it. That's all the questions for today. So I'll leave you, and I'm going to ask you again. Have you enjoyed the maths? What music were you listening to, and what was the artist? What was the title of the song? And I hope it was a good song. And once again, we hope to meet up again for some more Molly's Math later in the week. I think the next one will be the 8th of January. And it's a goodbye from me, and have a good day with all the rest of your learning. Thank you. Bye.